Go. Step 1 is divide your leading numbers. In parentheses, use a calculator if you need to. If we take a look at this example up at the top, we have 6 over 3. If we divided those leading numbers, what would we get? 2, right? 6 divided by 3 gives us 2. Luckily, that's in between 1 and 10. Nice and simple. Step 2, instead of adding our powers of 10, we're going to subtract your powers of 10. Anyone remember what rule that's called? Quotient, absolutely. Thank you. Quotient rule. If I were to cover up these leading numbers, right, 10 to the 8th over 10 to the 5th, we just subtract downward. That's our quotient rule right there. Step 3 starts with a big if, because we're not always going to need it. If your new leading number is not between 1 and 10, BETW/ is just between. That's right. Move the decimal. I want to make this easier to understand. Move the decimal. Yeah, there's no other way to say it. Move the decimal until there's only one number to the left of the decimal. I know that's kind of wordy, but at this point we kind of understand what that means, hopefully. Not hopefully. I know you guys know what that means. Then what we're going to do is subtract the number of decimal moves. It's pretty much always going to be 1, at least in this class. Subtract the number of decimal moves from your exponent. Let's real quick, I want to show you a little side by side here from the previous lesson to today. So on Friday we multiplied our leading numbers. Today we're dividing. On Friday we added our powers of 10. Today we're subtracting. Same step 3, except instead of adding 1 to our exponent, we're going to subtract 1 from our exponent. So today's lesson is the exact opposite of exactly what we did on Friday. So if Friday's process made sense, worksheet 9 went well, today will be fairly similar, just the opposite of everything we did. So with that first example, we had 6.0 times 10 to the 8th over 3.0 times 10 to the 5th. Get that written down. I'll give you guys a few minutes here to finish copying. Everyone writes at their own pace, so we'll take our time. Take a quick moment here, flip back to our table of contents. Last lesson on that list, 9/5, 0, 1, 0. Not 0, 0, 10, 0, 1, 0. Worksheet 10 is what we're going to get today. Yes? Exactly the same as Friday, except instead of multiplying, we divide. Instead of adding, we subtract. Exact same thing. Yeah. Good. If you already did that example, great. If you wanted to give it a try on your own, I love it. Let's go through it right now, though, and make sure everything looks good. So, if you guys have highlighters at your supply box, right?
Yeah.
Okay. Make sure everyone has 2 color highlighters. I almost forgot. My favorite part, highlighting. You're going to take your first color and highlight your leading numbers, which here are what? 6.0 and 3.0. And then, Devin, what's my powers of 10 here?
10 to the power of 8 and then 10 to the power.
That's right. 10 to the power of 8. 10 to the power of 5. So step 1. We're going to do 6.0 divided by 3.0, which, like we said earlier, is equal to what? 2. 6 divided by 3? 2. 2.0 is going to be our new leading number. I'm going to highlight those again, 6 and 3, just so we can see where they came from. Step 2, we take our 10 to the 8th over 10 to the 5th. And we do our quotient rule, which means we're going to subtract these numbers downward. 10 to the 8 minus 5.
10 to the 4.
Close.
Negative.
What's 8 minus 5?
3.
3. 10 to the 3rd power is our new power of 10. Sorry, I ran out of room there.
Oh, take it out. I had room.
9 minus 4, yeah, that would, or 9 minus 5, that would give us 4. So our final answer, 2.0. Well, what sign always goes times, right? 2.0 times 10 to the third. Because our answer is still going to be written in scientific notation. So I know that you're thinking of doing the opposite, but in scientific notation, we always have multiplication in the middle. The only thing that's the opposite is the process that we're doing.
So even if it's dividing, it's still always going to stay as multiplying?
Yes, because this is the notation here. Now the leading numbers, we divide those. Yes?
Yeah.
And the exponents, we subtract those. So those are the opposites from Monday or from Friday.
But do you keep the...
But our answer always has multiplication in the middle, every single time. Great question, great point to bring up. I appreciate that. 2.0 times 10 to the third. Questions I could answer about that before we take another look? Quick show thumbs. How does that feel so far? Thumbs up makes sense. Thumbs sideways if it makes a little bit of sense. Thumbs down if it makes no sense, which is fine too. Okay. Let's do one where we'll need a step 3 so we can see what that's going to look like. Let's do... 5.0 times 10 to the 8th. Nope, I just did 8. Whatever, we'll do 8 again. Over 8.0 times 10 to the, let's do 3. We did 5 up on the other one. I don't want to repeat both of them.
You won't really be repeating them because you have the same... Actually, no.
Well, we're going to change it up anyway here. So in your first color, highlight your leading numbers. What are my leading numbers here?
5.0 and 8.
5.0 and 8.0. Perfect. What are my powers here? Powers of 10.
8 and 3.
8 and 3. Great. So we start off with our little calculator here. 5 divided by 8 gives us 0.625. 0.625. Is that in between 1 and 10?
Yes.
0.6?
No.
No, if it starts with a 0,
It's
it can't be in between 1 and 10. It's less than 1. Right? So we'll come back to that in step 3, but keep that in mind. I'm going to bring my step 2 down here so I don't run out of room again. I'm going to highlight up my 5 and my 8. Now we're going to take 10 to the 8th over 10 to the 3rd. And do what with our exponents? Subtract 10 to the 8 minus 3. Remember, top exponent minus bottom exponent every single time. Subtracting down to give us 10 to the power of 5. Good. That's going to be our new power of 10, or so we think.
Oh,
Because when we put these together in step 3, we'd have 0.625, which doesn't look right. Good, your intuition is correct. It does not look right. Times 10 to the 5th.
no.
So, our leading number, we already established, is not between 1 and 10. It's too small, right? So, how many times are we going to have to move this decimal over?
What?
Once. There we go. One space over gives us 6.25. So what am I going to do with this 10 to the power of 5? Take a look back at step 3. What does it say to do? Subtract the number of moves from your exponent. So we're going to take 5 and subtract 1 from it. That's another one of those opposite procedures from what we talked about on Friday. So what this gives us, 6.25. Good. Is that between 1 and 10? Yes, it is. Times 10 to the power of what? 4. Exactly. Times 10 to the power of 4.
Is that all tonight?
That's going to be all for the notes. So let me show you real quick. Oops. How do I use this? Okay. So let's take a look at what would happen if we plug this into a calculator that can handle this kind of thing. So if we have 5 times 10 to the power of 8 divided by 8 times 10 to the power of 3 and hit enter, that's what we get. 62,500. Let me write that out. 62,500. Right? Where's my decimal at in this number? On the very end. Where do we want it to end up? In between 6 and 2. How many spaces do we have to move? 1, 2, 3, 4. 6.25 times 10 to the 4th. Is that what we got?
Yes.
Yes, it is. 6.25 right down here at the very bottom times 10 to the 4th. So we verified it. Obviously, you probably don't have this calculator. That's fine. You're not going to need it until you're like, I don't know, sophomore in high school. But we can plug that in and get the answer just like that. Okay? If we were to check this top one here, the first example, right? It was 6 times 10 to the 8th divided by 3 times 10 to the 5th. 2,000, which is the same as 2 times 10 to the 3rd. We move that decimal 3 spaces, 1, 2, 3, and we get 2,000, right? Just to show you that this process is not just some random sequence of events that we're learning how to do. Mathematically, it makes sense. Okay? This is kind of just a little shortcut way for us to get a good understanding of it. Just like that. So keep in mind that everything we're doing here is the opposite, except our answer still has a multiplication in the middle. Okay? So divide your leading numbers, subtract your exponents, and if you have to, move your decimal 1 space and subtract 1 from your power of 10. Give me a thumbs up if that sounds okay, at least so far, because we're done with notes. Nope, it's just like worksheet 9.